Dear students, this video is start with third part of active methylene compounds, and these include diethyl malonate, application of diethyl malonate in organic synthesis, and cyanoacetic ester. So first is what is diethyl malonate. So diethyl malonate is an active methylene compound which is directly bonded with two ester groups. So this is malonic ester. So malonic ester is the ester of malonic acid. So this is malonic acid, CH2COOH, CH2COOH. This is malonic acid. This is also an active methylene compound, and this malonic acid ester form is malonic ester. So this is called diethyl malonate. So this diethyl malonate is prepared by boiling sodium or potassium cyanoacetate with alcohol and concentrate hydrochloric acid. So in the first step, potassium cyanoacetate is treated with acid to form malonic acid. This is the salt is converted to acid and the cyanide is converted to acid. This is malonic acid. In the second step, this malonic acid is treated with alcohol. We know that acid plus alcohol is giving ester. So we are getting the diethyl malonate. It is a malonic ester. So this is the method of preparation of diethyl malonate. We are preparing from potassium cyanoacetate, which is treated with acid and alcohol. So now the potassium cyanoacetate, how we are getting this potassium cyanoacetate? Potassium cyanoacetate is obtained from acetic acid with a well-known reaction. This is HVZ reaction. This is Hell-Vollard-Zielinski reaction, which involved the alpha halogenation of acid. This is the acid which has a alpha hydrogen. This hydrogen is substituted by halogen chlorine in presence of chlorine and phosphorus. Any halogen and phosphorus, this is alpha halogenation of acid, and this reaction is known as HVZ reaction, Hell-Vollard-Zielinski reaction. So this chloroacetic acid is treated with potassium carbonate to form potassium salt of chloroacetic acid. Then this potassium salt of chloroacetic acid is when reacted with potassium cyanide, it will form potassium salt of cyanoacetic acid. So this is potassium cyanoacetate, which is treated as starting material, which is taken as starting material for the preparation of diethyl malonate. Now if we see the acidity of this CH2 group in diethyl malonate, similar, this is a highly acidic because it is directly bonded with two electron withdrawing groups. So after losing one proton, it will form a stable carbon ion, and this carbon ion will stabilize through inductive effect of these two electron withdrawing groups and through resonance. It is similar like earlier active methylene groups. Now, since it is highly acidic, so we can form salt in presence of base like earlier reaction. So this form is sodium salt of diethyl malonate. Sodium salt of diethyl malonate. And this sodium salt of diethyl malonate, if we treat it with alkyl halide, then it will be the alkyl derivative of diethyl malonate, that is diethyl alkyl malonate. So this diethyl alkyl malonate, if treated with dilute acid, this is hydrolysis with dilute acid, then it will form, the ester will form acid, dicarboxylic acid, and further heating it will lose carbon dioxide to form alkyl acetic acid. So from this diethyl malonate we can form alkyl acetic acid. So this is the application of diethyl malonate to organic synthesis of organic acid. So further, since it has two hydrogens in methylene group, so further we can replace this hydrogen also through the salt formation and reacting with alkyl halide to form a dialkyl ester. So this dialkyl ester will be further converted to dialkyl carboxylic acid, and further losing carbon dioxide will form dialkyl acetic acid. So we can convert both the hydrogen of this methylene to a alkyl group and the dialkyl group. So these are the application of diethyl malonate in organic synthesis. Next is synthesis of barbituric acid. So barbituric acid is a cyclic molecule which is formed by diethyl malonate and urea in presence of base, and this reaction is by the loss of two molecules of ethanol. So this is a diethyl malonate and this is urea, and we are getting a cyclic acid. This is barbituric acid. Similarly, we can form cyanoacetic ester. So cyanoacetic ester can be formed in a similar reaction like acetic acid. Similarly, HVZ reaction to chloroacetic acid, then treating this chloroacetic acid with potassium carbonate to form potassium salt of chloroacetic acid. Then treating this potassium salt of chloroacetic acid with potassium cyanide to form potassium salt of cyanoacetic acid. Then treating this molecule with concentrated sulfuric acid followed by reaction of ethanol, we will get cyanoacetic ester. This is the cyanoacetic ester, and this ester can be prepared with the similar reactions like diethyl malonate. And the cyanoacetic ester acidity can be again explained through due to this electron withdrawing groups. So it is highly acidic, so it can form salt in presence of base to form sodium salt of cyanoacetic ester, and treating with suitable alkyl halide, we will get that alkyl derivative of cyanoacetic ester. This cyanide can be converted to amine by treating with lithium aluminum hydride. This is a reduction. Then it can be converted to acid by treating with hydrolysis with dilute acid, and it can be converted to amide by partial hydrolysis with concentrated acid. Similarly, this ester can be also converted to acid, and further it can be converted to some molecules. So these are all about these active methylene compounds: ethyl acetoacetate, diethyl malonate, and cyanoacetic ester. Hope you are getting a brief idea about these active methylene compounds, and this video is the concluding video of active methylene compounds. So if you have any doubts, any query, then you can ask in the comment section below. Thank you.